be a series of session. Okay, so first we'll start with one piece of automation today, and in the upcoming week we will do the second part, so that when we connect both, we can do magic in our AWS automation. So what we're planning to do is we are going to do a solution where, let's say, some of the security component is being bypassed. For example, someone is creating a security group with an open port of 0.0 for, let's say, port 22, which means anyone can access into a server. So how can we detect this, and then how can we deploy a Lambda, and if Lambda is getting any of the change like this, to trigger a Lambda and then update the security group or even destroy the security group. So how can we do that? That's what the entire scope of the project we are planning to do. But the initial phase is something to split in the project, right? So we are going to take Lambda, and how can we provide the Lambda and access to update any of the existing resource, and that's what we are going to see in today's session. To simplify, what we are going to do is there is going to be an EC2 instance, and we are going to start and stop the existing EC2 instance using automation. The component we are going to use is Lambda, EC2, and then we are going to use AWS SDK for the end-to-end automation part. So let's go through the setup once. So first let me log into the account, and so I already had made the setup to make the demo simplified, but then we'll take you through like step-by-step process what's been done. So first let's explore the Lambda. So if you see, I have created a Lambda in the North Virginia region, and I named the function name as EC2-stop. So this is the Lambda, we are going to use it for our demo. Same way, I also created an EC2 instance, which is currently in a stop state. I believe I would have stopped it for the cost optimization purpose. So currently it's in stop state, and you can note the instance ID. So what we're going to do, we are going to use Lambda to start this instance. Same way, we'll also use the same Lambda to stop the instance. To do that, we want to provide Lambda the IAM role. So if you see under the Lambda configuration permission section, a role has been mapped, and if you go to the role, we can see the permissions, like what are the permissions that have been mapped. So one is the Lambda specific permission to update the log groups and put the log events, so that we can go and see like if the job is failing, pausing, what's the action being performed for each Lambda calls. Same way, I created a separate policy which would be doing a specific action, EC2 start instance and EC2 stop instance. I tried going granular level. If you see, I'm not providing EC2 full access since the Lambda needs to perform only start and stop. I went with this. One thing I've done here is like keeping resources star, which means this Lambda could able to start or stop any EC2 instance in my account. To make it more granular level, what you can try doing is you can add conditions based on like tag based. Say if any EC2 instance consists of a specific tag, then only you need to stop and start, so that you can categorize your application based on tags, and then you can automate more further and going granular of access. So for now, to keep it simplified, I went with the granularity of action level, and I provided the resource to of any resource of EC2 type, so that it can start or stop any of the instances type. The code wise, if I go to the code I here uses the Node.js one. And if you're someone new here, like we already made a video of the AWS SDK version 3. I followed the same guide. So to recap, if I go to AWS SDK v3, and if I zoom in a bit, you can see all the services here. So I went with EC2, and then if you come down, we are going to start the instance, for example. So I can see this is the command we are going to use. You can even read the description what it does. And if I go with start instance command, it's give you a code snippet itself, like what is expected one, right? So to recall what we have, so we are importing the AWS SDK of type client EC2, and then of EC2 there are like multiple actions are there, right? There are like list EC2, update tags, a number of calls were there, whereas we are going to import only the start instance command. So that's the advantage of v3 we have seen in the past, where you don't need to import the entire SDK or end client EC2 type of API calls. You can go granular level, like what command you want to import, you can do that. So then they're expecting the config. So in this place, you would generally pass details like what region the EC2 instance exists, those kind of details you would pass. But in our case, both my EC2 instance and Lambda lies in the North Virginia. So I would leave it as empty. I can show the actual code. And then within the input field, you're going to pass the instance ID, and then you're going to make the call for start instance command, and then you're passing this specific input variable over here, and then we're going to execute the command to start the instance. So if I go one step back of client, and then if I search for stop instance, and you can see quite similar. Instead of start instance, you're going to use stop instance, and then you have additional options like hibernate, dry run, and force. So these are the actions which you can make to the EC2, either to hibernate it or stop or start, those kind of stuff. So for demo purpose, I'm going to use the same Lambda for start and stop purpose. So what I've done in the code is I've done pass the both the stuff here. So instead of just stop, I also use the start, and I'm starting the handler over here for Lambda to, whenever I trigger a test call, what's going to happen, and the rest of the codes remain same. So in this case, like it's for stop API call. To start it, I can just comment it, and you would need this part, and I can deploy the Lambda part. And if you see the instance ID here, I used is the same instance ID of the EC2 part. So when you are going as of Terraform, for example, or infrastructure code, you can create the EC2 instance as Terraform, fetch the instance ID from the Terraform code, create a Lambda, and then pass this as a variable, to your code, so that it can be handled dynamically of your applications. And it's an array, so you can pass more than one EC2 instance. So now if I do a test call, or if I trigger the part, you could see it started executing, and for now I'm not printing anything, that's why the response is null. But then if you go to the console, and if I refresh it, you see the states change from stop to pending, and then it will slowly get the instance started. So with Lambda, with right permission, with right SDK calls, we are assessing another service API functionality. So same way, you see now the instance change to running state. Now let's fine tune our code or retune it to do the stop action. So let me do the stop instance, and let me comment the start functionality. And if I just deploy it and test the code, so now if you go to the console and see, if I refresh it, it started stopping part, right? So simple click button. So now you can ask like, hey, you have two codes, how do you trigger it in each time? One as a start and one as a stop. You can do a trick with the help of versioning. So if you go for the deploy state, right, where it is, so these are versions, and you can do like public new version. Let's say public, the new version, it's going to be like stop the instance. Let's say publish it. So now we know the version 1, it's going to perform the operation of stopping the instance. So now I can go back to the code, and I can comment back whatever the operation that was doing the, sorry, let me do the update code. And if we go to the code, let's comment what are the operation that was doing the stop functionality, and let's uncomment the of start functionality. If I do deploy, and before triggering, I can go to the versions, publish new version. So this is for stop functionality, right? So it might be, so this is start functionality. So if we go for versions, publish new version, start the instance. So now you know, if I call the Lambda of version 2, it's going to perform the start functionality. If I'm going to trigger the same Lambda code of version 1, it's going to do the stop functionality. So same Lambda, when triggering you can control. So for example, it went to stop state, go to the Lambda and go to the specific version. You can go to EC2 stop versions, and I need to start the instance. So I do this. Let's go for the code version 2, and I can trigger this one. So when you trigger the Lambda, you would generally specify the version number at the end, right? So by that you can do that. Also, you can see you can add a trigger prior to it. Like you don't need to come and do the test part each time, right? So for example, if you do a test call on version 2, so it's going to start the instance, and if you go to the code, go to the where is it? To stop versions. Now if I want to stop it, I can go to the specific version and then go to test, and let's finish the booting part. So that, okay, now it's running. So if I go to the version 1 and again I initialize the version 1 now, and you would see it would start into the stopping state. So same Lambda, with by versioning you can reuse the purpose, like which one is for what, right? And you can add trigger to it. So you have, let's say you want to trigger every morning or every evening. So you have the event bridge, and you can configure the schedule over here. Like every morning I need the specific instance would be triggered, or you can even have the cron pattern over here. So you can provide the cron expression, like when it should be, the Lambda should be triggered, and then you can explore like 021. So here what's happening is this 0 is for minutes, okay? So which means if my event should trigger at sharp 8 o'clock, 8 p.m., which means the minute is going to be 0, right? That's why we added with 0 here, okay? And then this is going to be for hour. What hour it should be triggered? Since it's PM, I went with in railway format 20, and this is the wildcard for day of the month. So ideally they expect like 1 to 31. If you want to execute irrespective of what, so we went with the wildcard parameter question mark here. And then we have month. So again, we want to execute irrespective of the month, so we went with wildcard start. So here, as per AWS, they're going calculating from Sunday being 1 and Saturday being 7. So since today is Sunday, we are recording, so that's why I went with 1. And then the year, so which year you want to execute. So they are giving the granularity for like year as well. So let's say if you have a use case only execute every month till 2024 ends, then you can provide the year as 2024. But since we want to execute like every year, we went with wildcard state. We'll see. Oh, okay. So actually you see like added trigger for version 1. So version 1 would stop it. So let's try doing a trigger for version 2. So you can add trigger like per version as well. So the version 2 is going to start it. So if you go for add trigger for version 2 specifically, and you want to go with event bridge, let's say create a new rule, start. Now we know what we are speaking, so we can go with 0. Time, let's go with 8. Day of the month, we don't care. Month, we don't care. Then we have day of the week, so you would need to go with Sunday, and then here we don't care. Just the minute, we will go with 6, right? So that at 8:06 it should get executed. And right, so let's say I think this is in UTC timing. So how can we change it to UTC? So UTC is like 2:34 p.m. So let's go for it. So for 2:34, it's going to be 14, and let's keep it for 36, right? And let's add this. It's been added now. So at 2:36 in, so current timing is 2:35. So in 1 minute we need to see the EC2 instance being turned on, right? So in editing, I will add the boom boom music, so suspense music will be there. We'll see. In so ideally, it should get trigger the lambda, and then we should see. So we can see the is the lambda is getting triggered or not. You can evaluate at monitoring section and see. You see there's been like triggers been happening, and you just need to wait for like one more minute, and we should see like an event gets triggered over here. So go with 1 hour, and we can see. You see the event bridge got triggered, and now the instance changed from stop to converting into start state. So let's change the timing for stopping the instance as well. So if we go for versions, and to stop the instance, we added the trigger, right, of event bridge. Let's modify this. So let's edit it and let's modify it. So the current UTC is 237. So let's go for 239 and let's update it. Okay, so we updated the instance now, or the trigger now. So once the instance is its running state, in by 239 we should see the instance gets stopped. So we can use event CloudWatch event and invoke the lambda to on and off. Again, we versioned it like one for starting the instance, one for stopping the instance. So you can have like everyday same lambda with two different versions for two different purpose, and then say like turn this instance every day morning 9 o'clock, or like turn off every weekend Saturday 6 p.m. and turn on Monday morning 8 a.m. So this can be a use case for your non-prod instances, and you can even go granular level. Like so, currently we are passing the instance manually. You can go in terms of like adding additional SDK calls. So for example, you can go for listing out the instance, right? So if you see list, so there should be definitely API calls to list, or they would be calling it as get. Let's see, get TCD instance. That should be like API calls to get all the instances for sure, and then you can get the instance ID out of it using the custom code. You can even read tags of the instances using API calls. I will leave it as a separate project for you people, like if you want to explore, but this will act as a standard guide like to kickstart of on and off. Now you see like it's 239, and if we go for the instance, yeah, it started stopping. Now we made a small automation in terms of using lambda to on and off the EC2 instance, and we even added a trigger, a simple trigger of cron tab using a CloudWatch event. So you can do it. Same way you can replace EC2 with something else, some other service, some other SDK, then your automation is done. So next week we'll talk more about replacing the event trigger with the AWS service called config, which will sense if anything security breach or anything added, and then we will rectify the breach automatically. Any doubts so far? What you have seen? I